So all the objects, it gives out infrared, gives out some form of energy based on uh, based on its own energy, as in, or based on the temperature that it is in. Say, for example, you would have what was can you remember what is the color of the flame when you turn your stove on, gas stove on? So that's blue, right? Okay. So what is the color of let's say, like when you heat a metal to almost to its melting point? Do you remember what is the color that it was glowing in? So based on the temperature it is in, temperature of that particular object, it glows in that particular spectrum of light. So each object um, radiates the energy based on the temperature that is it is in. Similarly, we also have some temperature. So you know the human normal temperature, right? Human functioning temperature. So we also give out infrared light as we are also um, since we are like hot warm-blooded animals, we give out some energy. We need some temperature. We emit some temperature. So because of that, infrared heat signatures can identify people and also some other objects. So infrared heat signature can be used to identify objects, or what we can do is we can create temperature-based imaging that remain visible even in complete darkness, fog, or smoke when traditional visual systems fail. Okay. So one thing is what we can do is we can use heat signature to identify people um, that you would have most commonly have seen. So on the other part, what we can do is, let's say we are traveling on a car and it is a very foggy day and the visibility is very close to none. So what can be done is we can shift to like infrared sensing, infrared imaging. So in that case, what would happen is infrared light would be used to perceive the objects that are in front of your automobile, let's say. So what would happen is when that infrared light is emitted and it bounces back from the objects, or you just image the objects that are in front of you, based on the temperature change, it can be we can identify any let's say obstacles or other automobiles, or let's say like a change in our path. All of these things can be identified just using thermal imaging. So we'll see how image intensification process can be used to visualize. So first off, what it happens is it light is being captured. So the objective lens captures the ambient light or photons from moon, stars, or whatever form of light that was nearby, or even infrared sources. So the small amount of photons are absorbed. Post that, we have conversion process. A photocathode converts incoming light photons into electrons through photoelectric effect. So you remember the photoelectric effect, right? So through photoelectric effect, the incoming photons are converted into electrons through the photocathode. Okay. So now we have electrons replacing the initial photons. Suppose that we have something called amplification. So what amplification does is a microchannel plate multiplies electrons thousands of times through cascade effect. So through cascade effect, the number of electrons will be multiplied into several folds, and then these electrons they hit a phosphor screen. The phosphor screen grows in its characteristic green visible color. So this phosphor screens, electron heating phosphor screen will give us a visualization of the same image that was captured initially with the low light or almost no light scenario.